I have to go to technical.
Oh, you're trying to set them off.
Measures. It's not science. What I actually activate for going to the person where I'm following. And then there's what actually activates data, which of course goes into their like, I'll get in the so. Right. And then there's, oh yes, I'm still working on IETF outreach and I got non-com and so these are some sort of. Yes, exactly. And then she put on the nice SCP field for a while. Someone else's problem. But, you know, then coming back, it's like, I learned the context and it's very practices. I'm sorry, I've been because IPM for years.
Check. Okay, that mic's on.
Exactly.
Yeah, well, okay, yeah, we're going to go ahead and start. So if you're presenting, you get to see your slides down here. If you're watching, you can see the slides over in the Meet Echo, or you can maybe even log into Meet Echo. There's just some problem with getting the signal off to. So I'm going to introduce you, and you're just going to run the thing. Sounds good? Yeah. All right, so hi, I'm Brian Dremel, co-chair of IPPM. This is IPPM. I see a lot of familiar faces. So I'm assuming pretty much everyone's in the right room. Hi, Leah, welcome. I'd like to first introduce our new co-chair, Tommy Pauly. He's be running things today, basically. Yeah, okay, so everyone, welcome Tommy, and let's have a meeting.
All right, welcome to IPPM, everyone. I'm looking forward to joining you. And apologies if I don't know everyone super well right now, but I trust that everything will go great. So let's just go through the administrivia. So here is the note well. You have seen it before. Make sure you do note it. It's slightly changed. Yes, note it well. Yes, we so Sweta is taking notes for us. Do we have anyone who's going to be jabber scribing? Okay, Brian, thank you. All right, so a quick status update on just the some of our working group documents that we're not going to be talking about this time. We have two documents that are in the RFC editor queue. One is the IPv6 edition to 2330. And I think that one is just in the edit state, so there's nothing particularly new to update there. The TWAMP Yang draft does have its IANA marking gone through, and it's just, I think it has a dependency on another draft reference, and yeah, misref. So I think that's just waiting on the inline document. Yep. Great, and then we also have a working group last call on the TWAMP test document that went out a little bit ago, and that ends today. I think we've only had a couple responses, just saying, yeah, it looks fine. If there are any other concerns, please bring those up.
Excuse me, only have this small screen?
Yes.
We cannot use
They've
this
been
one?
notified. We're working on it.
Okay.
Sorry, yeah. That should hopefully be fixed as soon as possible. Yeah.
Could I get one person who has not yet said that for TWAMP test is okay to stand up and say it's okay, so that we can say we've got enough people who paid attention? Excellent. Thank you. Oh, footer, yeah. Okay, perfect. Good. It's good. So working group last call is now complete. We will, I guess, do we have a shepherd assigned to that already? I'll take a look and, yeah. Okay. Yep. We'll get it moved along. Thank you.
All right, so we have a fairly packed agenda, so let's get moving on. We're almost at the end of our 5 minutes for administrivia. So we're doing that. We have updates on the initial, on the metric registry and the initial content of that registry from Al. Following that, we will have a number, we'll have a update on the IPPM route draft, and then a whole chunk of IOAM updates. Following that, we have two other drafts that are not working group items yet, but have been brought up to the list and have had some discussion. So we'll be going through those. And then at the very end, we have some time allocated for lightning talks. These are going to be limited to 5 minutes at most each, and we will get through them as we have time. So any agenda bashing on this? All right, let's go. Al?
Everybody's had it? You guys have the blue sheets up here? Everybody's had it? Okay.
Great. Please save our projector.
So without further ado, I'm Al Morton, representing a...
Mike.
Oh, we got to do the mic, don't we? Well, everything else works perfectly. So I'm Al Morton, and this is the initial registry contents draft that you see displayed there that we've been working on, obviously for a long time. But that's the draft that feeds into the performance metrics registry draft, which has another long list of people and has also been worked on for a long time. So the really quick summary, because I want to get to the discussion. I think you're going to quickly assess the fact that I would like to see this done. I would like to see both of these done. And now I can see nothing. You can or there. So anyway, let's see what happens here. Perfect. Great. Now everybody's back online, even me. So here's the quick overview. By the way, who's read these drafts in any version? There are, okay, several hands coming up. Thank you. There's a lot of years of work here. So if you're interested in IPPM at all, this is something you really ought to be taking a look at because I'd like it to be done, as I said. So we're solving a problem here. All the original RFCs for loss and delay and so forth, they were written with great flexibility. We're adding precision here now so that if you make the measurement according to the way the registry specifies it and you do all the things the registry says, you're at least starting out with two fairly identical measurement systems. You can still probably do a few things wrong, but you know, you can't fix everything like that stupid thing. So it really applies to all of these: active, passive, and hybrid. I want to be sure that that's clear here. So passive measurement people and hybrid measurement people, you should be reading this. This is the first time we've had no substantive revisions in the registry itself. So that means we're also closing in on the truth and or point of diminishing returns. This is what the registry looks like in a graphical form, where you can see we've got these different categories of summary, metric definition, methods of measurement, the outputs, administrative info, all that sort of thing. So that's the quickie summary. So here's what happened in versions 7 and 15 respectively. This is going to hit all of you authors and editors. RFC 2119 was updated by RFC 8174. And as Tommy just reminded us, we've had a couple of drafts just moving through IESG, and we got dinged on the fact that neither one of them referenced 8174, which updates the terminology in a nice way. If it's capitalized, now it's supposed to be taken as this definition. So everybody needs to do that. Enough said. We've revised the passive TCP metric. Jakob Stein provided comments as planned. It would still be good to have a look at the heuristics for the methods of measurement there. And my friend Brian Tremmel, who's here somewhere, he's offered to supply comments on this a few times. I really hope you could find a moment. Yeah.
We can definitely improve the heuristics if we get some review there. So we clarified, thanks to Ignacio's comments, mail with me. DNS, which is in section 6, it's a response time and response loss metric. We've clarified that that's from the user perspective. There was some thought that we might do some more complicated things measuring DNS. We're not. It's just this simple thing that everybody else does. They do the user measurement. So discussion points. We got here in like a minute. That's pretty cool. So now's when you all sort of rush to the mic and give me feedback on these
critical points of interest. For DNS response time and loss, we need a way basically to track the fact that a given request has either been responded to or not. And for that, we need the equivalent of a kind of sequence number, something to determine correspondence between the requests and subsequent requests that we make. So the offering here is that we could use a random source port, or we could try to populate the ID generation, which may or may not be supported. Brian.
Hi, Brian Trammell speaking as an individual. So random source port is part of type P, which means you might get different path treatment. So don't do that.
Okay.
DNS has an ID field, right? You
Yeah.
put a query ID in, so you can just actually
Just do
Yeah,
that.
right,
All right.
just do
all right. Does anybody have any feeling for how well that's supported, though? That's the question.
wait. So no, I mean, wait. There's an ID in the query, and the response refers to the ID. So like DNS doesn't work if you don't use it. So it's not a very
So it
big
doesn't work
space.
if you don't do that. Okay.
It's not a very big space, right? So you're actually then limited. I think it's like 16 bits.
That's big, 16 bits big enough. Big enough.
Well, it means you can't have more than 64K outstanding things to the same server at the same time. So it depends on.
I don't want to do that.
You might not want to do it. Somebody might want to. I'm just saying it's a limitation, and you'd have to actually talk about it in that
Okay.
case.
Okay.
Or you note that it's 16 bits, and then people who want to stress test DNS servers will understand.
They got to go to another
Yeah,
IP address
exactly.
if they want to go.
Yeah.
Yeah. So
16
All right.
bits.
16. Good. That's plenty. Great. Okay. Let's consider that. Well, actually, we're not going to consider it resolved until Nalini speaks.
Thank you. You know, not to throw a bunch of monkey wrenches into this, but DNS is getting encrypted all over the place and being all different. And I mean, I totally get I know. I mean, I get the transaction ID indeed is there in unencrypted
Yeah, but
DNS.
we're the endpoint. We're the endpoint here, so we'll get that. We're in the world of relieved opacity.
So this is only for non-passive?
Yeah,
Or
yeah.
you're
This is active.
thinking-
This is active.
Okay.
Yeah. Okay, thanks. Yes. All right, so that's one. So then we have this other point in section 8. We've got this one specific metric for UDP, one-way delay and loss. There's probably delay variation and things like that there too. And we left this open so that people could provide, have some flexibility about the packet stream that they're generating and so forth. But my tendency is that we should make this fixed time parameters or fixed parameters that we choose for the packet periodicity, for example, and the packet size. So any thoughts on that? And does anybody have any preference? In other words, would you like to sort of keep this VoIP like? That's the typical thing for periodic. No opinions. All right, so we'll try something, and we're going to make it fixed. And then if we don't review it, then we're all going to live with it. How about that? There are tons of measurement systems that do something that's very VoIP-like, so I don't think we can go wrong if we go that way. But good, thanks. All right, so next steps, open issues for TCP out of review. I think we solved DNS response time, and the other one I'm going to take a shot at. I know that we got input basically from the XR block folks. Rachel, you were thinking about adding some metrics. You guys looked at I went to the meeting. You guys looked at the registry. Jonathan was kind of flipped out by the size of the document and how big the reference, each entry was. But it's an RFC too, so it has the function of being an RFC for these things as well. So yeah, I think you guys agreed to work on some new metrics. Just nod or say no. She's coming to the mic.
So I guess right here.
Yep.
Yep. So in the last meeting we discussed this, and I think some people may think that have a registry would be useful.
Yeah.
But some people may still think it doesn't have value to do that. So
Oh, okay. Okay.
that's some people apply or
So,
something.
so,
Yeah.
so this may not happen. That's what you're saying.
May not happen. I think it needs to see people how many people interested in this and want to contribute in this draft, I think. So maybe it's still more discussion, but actually kind of the Excel blog doesn't have any new work and have
Oh, okay.
meetings this time, so we didn't.
All right. So that's a factor too. Got it.
Yeah.
Got it. Okay. Good. Thank you.
That's,
Thanks for the reminder
Could you
about that.
make sure you share your name with the note
yeah,
taker?
Rachel,
Rachel,
Rachel from Huawei. Yeah.
thank you.
And incidentally, the blue sheet's up here for folks coming in late that might want to sign it. All right. So really the TCP section heuristics is where we're looking for more review. And that's it for this one. So I thank you for your feedback today and the status reports and stuff like that. Cool.
Thank you.
I'm up next.
Yes, I know.
So I won't go.
And also just one comment on that, because I'm fairly new to these, and so I was reading through these documents. They are quite long, but I think they're very well written. They're a very good introduction to the space. And so not everyone did raise their hand on this for having read it, so I encourage you to go through it and do give feedback, because these are important.
Really cool. Thanks, Tom. Okay. So this is a completely different talk on a completely different draft. It's the Advanced Unidirectional Route Assessment, which I'm doing with Ignacio is the first person there, Joachim is the third, and Carlos is the fourth, and I'm Al. So here's our quick background. We got this going really in draft form far before IETF 99, and we worked it through to adoption in 101, got lots of good comments along the way. So that's jumping quickly to the good verbal feedback we got from the last session, that we needed to qualify what can be discovered here for the kind of the active and trace route methods. And we've actually done that 3 times in the text now, so it can't be missed. We've got the new methods where we've moved them now into the methodology section on temporal composition and this routing class C that we've been talking about and waving our hands about. Those are in the new methodology section. We're kind of referring to existing tools there for sure in terms of parish trace route. In fact, when we started this draft, Brian's first advice to us was start with parish trace route, and that was a good place to start. And then the IO and A&M stuff appeared as we were working on it, and that was another place to start in the hybrid space. So we also had comments about let's incorporate MPLS in here somehow. So we generalized our definitions to do that. But now we've actually got a proposal for an appendix, which we included in the draft text from Rudiger Geib that talks about MPLS. And Carlos has reviewed it. We got a few things to fix there. Anything else on this? Oh yeah, and on the reporting section, we basically said, look, there's a place, this RFC where we talk about storage of trace routes. That's in retrospect, that's not going to cover everything we talk about here, and I think I'll get to that in a moment. Actually, I'm going to, because I'm in control, I'm just going to go do that. So, trace routes are composed of hops. Each route is represented as an ordered graph. So this is the ordered graph for a single member route. And by designating the host with this HIJ terminology, we can actually make a kind of a multi-dimensional tuple here. It has to include the host identity, but all the rest of the things here are optional, like the arrival interface ID, departure interface, arrival timestamp, and a round-trip time measurement that went along with that information. So this is what a route ensemble looks like, skipping the source node. And so this one would cover, multiple cases. Anytime you have a unique route where some of the hops change, now you've got a different member of the ensemble. So that's the quick background here. All right. Yes. So in version 2, as I mentioned, we've worked hard on temporal composition for route metrics. Why? Because if you've ever done trace routes and then done it again and done it again, a lot of them, the results are highly continuous, repeatable. You get the same answer many times. That's the way to put it. What you would basically do is kind of reduce your repetitive tests to the cases that are interesting. And we're kind of saying that really the load balancing places are the ones that you really want to look more and more often. But we've got heuristics that basically say, look, if you see anything else change in a spot check of the other things that you think are constant, now you got to rerun the whole thing. So that's what we've got in there for temporal composition. It's not a predictor of the future. It's just using the past to try to reduce the amount of test time that we're taking up. So now we've identified that there are some load balancing hops in our trace route. And what we've observed there is that load balancing hops treat packets of what we're calling a routing class C equally. And we've talked about this this class C concept many times. It originally appeared in our original framework, and we have, let's say, enhanced it and better defined it in the RFC 7799, which talks about active, passive, and the hybrid methods of measurement. And it would potentially be a metric parameter that we would use in this work. So going back to our terminology, each member route of a route ensemble has a routing class C. And I should say the thing about why I'm using this word routing, this adjective routing. There used to be class C addresses, and it came up in discussion that people flipped out that we thought we were talking about class C here for the old address space, the classful address space. We're not. It's a fully different class C here. So as I said, each member of the route has a class C. So there's synergy with the temporal composition in that now, the kinds of things that we're interested in determining about the load balanced portions of the path, temporal composition actually helps us determine those and avoid testing around them. So we think it's very useful to know. In fact, it says that both in 2330 and 7799. And then your line is, how useful is it? Come on, pay attention, everybody. Let's get with the program here. This is supposed to be an active discussion.
I think it's hybrid.
So route measurement at a midpoint. Has anybody ever heard of this? Has anybody ever done it? It becomes important when you make a midpoint passive observation of a stream that you can only sort of observe. And because you observe that stream having a problem, what happens next? You want to figure out where the problem is, right? Maybe it's got a round trip time larger than you might expect. Well, where's the congestion happening or the delay variation that's causing that round trip time to expand? I think this is a great idea, but how can we do this? Well, at the Hackfest, I hacked around with spoofing the source IP address, and I figured this would work, and it actually has to work if you can observe both paths through your observation point, and that's one of the things that we, at least in this path, that you should be able to do. The bad news about spoofing your IP address or somebody else's IP address is that now they're going to get unexpected, destination not reachables from certain points along the path. Probably not good, not good. But but it's an interesting way to start this, to sort of see, okay, is there really stuff out there that we can look at? So it turns out the end-to-end flow conforms to a specific routing class C. So it's going to have a lot of flows around it in terms of source address and destination address, source port, destination port, and protocol, which will also fit in that same routing class C. And now when we're at this midpoint, we can launch new flows. We can examine the RTT to intermediate hops, and we can perform other diagnostic measurements from that midpoint. And they'll follow the same path as long as they're part of the class C that our flow of interest has helped us to define along with the examination of the route. So I think that's a cool thing. And I think it also is partly answer to the question of, if you guys measure this RTT at a midpoint, what are you going to do with it? This is one of the things we could do with it. So it's a plus. Any comments on that? Anybody want to help? I don't want to go first next time.
No, I don't want to help. I don't want to help write text. I do want to help hack on some tools, and I'm going to. I don't think he's here, so I can volunteer on his behalf. I'm going to volunteer Yari to also do some hacking on these tools, because this is so. It's interesting to me that like traceroute is kind of old and boring and dead.
Not dead, but boring.
I mean, so if you look at like almost all the like most of the trace routes sort of in open measurement now are done on ripe atlas nodes because it's a huge network. And if you look at the code in the ripe atlas node, it's actually got comments from Van Jacobson in it. So it's like the original trace route, right?
Yeah.
So it's old. There's other stuff that you can do in this space that's really interesting. So I'm going to put my chair hat back on now. A lot of this stuff is actually new. We're developing new algorithms for traceroute-like stuff. So Yari's interested in this too, which is why I'm volunteering him to take a look at the document and look at his sort of, he's doing a little bit of hacking around on stuff like this. It makes me wonder about the status of this document. So what is it now? What are we targeting?
Oh, in other words, for the milestone?
No. Well, no. Like, so intended status, intended document status.
Oh, standard track. Standard track. Yeah, it's a
Yeah.
metric. Yeah.
Okay.
But
right.
there's, I mean, when we're talking about methodologies,
Yeah.
and we're talking about tools to back up the methodologies.
Right.
And I've like I said, I've started hacking around with Paris Traceroute, the MDA
Yeah.
version of it.
Okay.
For me, it's all about results presentation.
Yeah. Okay.
Once we determine what Class C is, routing Class C, that helps us determine, what other things we can do from that vantage point.
Okay. All right. I buy that that's still good. All right. Thanks.
Okay. All right.
Any other comments?
So we've got some to-dos, some of which we've done. Actually, we did the first one about investigating Paris Traceroute's V6 capability. It's got it. We have some other stuff to do there, especially adding cautions about the methods. We've already added cautions about the metrics, but you can probably say some things too that are useful about what happens when you use good measurements badly. I think, and we did an MPLS appendix, so but we've got more to do with that. So we need to complete the work items, working group and authors. Continue your review of the temporal methods, the Class C methods, the multi-point detection, multipath detection algorithms stuff. Look at tools for this. I think you'll find that that's valuable. All the material on that topic is in section 4, and we're still looking for review for the later sections, which Ignacio is the primary author of, and where he's used the round-trip delay to do analysis to find things like congestion points and stuff like that, determining link types and so forth. So that's all to do. I think that's it. Yeah, that's it.
Any more questions, comments on that?
Volunteers to review the draft? Aaliyah?
Great. Thank you, Ilya. All right. Thank you, Al.
Thank you. Thank you all.
All right. Next up, we have Frank and many IOAM documents.
Many others,
Yes.
right? Okay. Yeah. And use a clicker. That's
Use a
nice.
clicker.
It even works. Cool. This is an update on a variety of drafts and a couple of new drafts. And Mickey is here. It's going to go help with a raw export draft. So we'll talk about the main data draft that we have adopted for a while now. And we're talking about a couple of individual contributions for now that we're hoping to get adopted very soon on encapsulating IUEM data into VXLAN GPE, Geneve, GRE, and now also IPv6. There's a new draft on that. Well, the obvious question is, how do you get the data off box? We have an export draft for that now, so that the decapsulating node can go and export the data. We're not munching around with the data, we're just exporting it, which is why it's called raw export. And then mostly as an FYI, the SFC working group between last meeting and today has adopted a draft on IOM NSH encapsulation, so we're making progress there. And they also adopted the proof of transit draft, so to actually prove that a packet made it through a sequence of hops. So that's related work. One topic that came up, and it also spilled over to a couple of other mailing lists, was that the section that we had on layering IOM data wasn't really entirely clear. And so we updated that one section with yet another, well, half a sentence, basically saying, well, you can have IOM data in one protocol, like VXLAN GPE or Geneve or NSH, and if Geneve happens to run over IPv6, you can have IOM data in the layer below, like the V6 layer as well. And it doesn't necessarily need to be kind of from the same operator, obviously. So you can go and put that data because, well, the one link might be operated by the guys who runs OpenStack and has the Geneve overlay, and the underlay might be by the V6 underlay operator. So we try to go and clarify that. Hopefully that's good enough for everybody by now, because, well, after proposing that language also publicly, we've not really seen any further comments. What we also clarified, and that's based on a comment of Tom Herbert, is that once you do the encapsulation, you should closely follow the recommendations for reuse of port numbers or use of port numbers in 7605, which basically says, well, UDP port numbers are not globally unique if you happen to have an uncontrolled environment like the global internet. So don't touch content just because it carries a Geneve UDP number. The content might not be Geneve. So don't blindly update information in transit nodes because you believe it might be IOM data carried within Geneve. Don't do that. And so there is a must not statement for kind of global internet deployment in the various encapsulation drafts that we're going to discuss in a second. Then we also started to do the laundry that we promised in the last meeting, largely around the security section, and many thanks to Tel to go and do that work. So there is now a variety of potential attacks that you can go do if you have IOM present. So obviously you can fake the IOM data to make the consumer of IOM data believe that the information, well, leads you to failures that don't exist, or you can kind of capture failures or hide failures in a positive and a negative way. You can, well, expose network information to people who shouldn't know that, well, the network information is there. So you can get an understanding of the network topology despite the fact that you don't want to go and expose that. You can use it to consume resources because we add data to the packets, so we increase the packet lengths. That's potentially bad if it's uncontrolled. We consume resources. That's potentially bad if it's uncontrolled. So all of these things are potentially bad if they're uncontrolled. The good thing is IOM is defined for a constrained domain, for an operational domain, as opposed to it runs on the global internet. So all of these things need to be taken into consideration. So we've basically listed all the bad things that can happen. One thing that came up also with the layering discussion, and I touched on that briefly, is if you have a Geneve layer and you have a V6 layer underneath, we always refer back in the document, like all the information that we have, a node ID, a interface ID, that's all its own namespace. It all relates to a domain, an operational environment. Do we ever, in any shape or form, on the wire or anywhere else, identify that domain, that namespace? We don't. So that's an area that we still believe we want to go and do some cleanup on, because we refer to the network domain. So we refer to the namespace, but we don't carry the namespace identifier anywhere. Because if you have that namespace identifier, if you just export data, then, well, the exporting information would not only have the individual node ID, i.e. 13, or interface ID 25, but you also have the context that tells you, okay, this is the namespace that this information is relevant in. So what we want to go do, and that's a proposal, and I want to go and hear feedback from that, is add a namespace identifier to, well, top-level IUM data. So that you can say, well, this is the namespace that I refer to, and all the additional data that I have is to be understood for within this particular namespace. And, well, if we had this, it also helps us with some ambiguity and some additional requirements that we've seen floating around. So there is a couple of drafts that we've even seen being read out here about limitations that you see with the current IUM data field definition. So people dream of additional fields for specific use cases. You can say, well, there is a couple of fields in IUM today that are almost free format. We had app data, for instance. App data is 32 or 64 bits free format. Well, so it depends on the namespace how you interpret that. Now, if we have a clear linkage to the namespace, well, then somebody can say, well, this app data means GPS geolocation for my specific use case, or it refers to a template ID, like what the IFA guys want, so that an individual node can say, well, I updated just this portion of the overall data in the IUM field as opposed to all the things. Or I can say, well, this app data is to be interpreted as, well, inter-packet gap. So if we have a clarification of this namespace, I think we make it far more clear that certain things are really contained within a context. And so I'd love to hear more comments on that later on as we go into the discussion. So that, I think, is the updates or the considered updates for the data draft. Then we have a bunch of encapsulation drafts, and we briefly discussed them in the last meeting, and they haven't really changed much above and beyond the discussions on layering. So we added a couple of additional notes there. So we have an encapsulation draft for VXLAN GPE, and the format is almost always the same. So we add the IUM data fields just after the typical shim header that you would use for one or the other encapsulations. For VXLAN GPE, we use the next protocol header, and then you typically have the typical structure, and I think I can't walk there because then the mic's not walking with me. You have an IUM type, you have the header length, and then you have an indication for what the next protocol would be so that you can go and chain the whole thing in. That's with VXLAN GPE. In Geneve doesn't really provision for anything next protocol structures, but Geneve has the benefit or the ability to go and carry TLVs in its own header environment. So in Geneve, we're just using the available TLV format capability so that you're using in Geneve, you're using an option class for IUM, and then the type is either one of the four types that we have in IUM, i.e. pre-allocated trace, incremental trace, end-to-end, edge-to-edge, end-to-end, or proof of transit. And so then, again, you just slot in all the data that you would naturally have in an IUM context. Given that we've done the reformatting earlier on in the last revision, the IUM space is almost self-contained by now. The same goes for GRE, and with GRE, I think that's the de facto and the easiest way to go and do IUM over V4, because all you would need is spend 4 bytes to go and slot in the GRE header there, and then, well, you can go and again dump in the V4 the IUM information. And what is new and just recently published is we have a draft for IPv6 by now. The information was roughly out there because we had an informational draft that we put out early on, mostly just to appraise everybody with what can be done, to showcase that IOM can be carried in V6 options. And well, if you read through the draft, it basically just says, well, you use the option of choice that you have in V6, the extension header, to go and slot in the IOM data. So that means for E2E, you're using destination options because they're running end-to-end. And for everything else, like incremental and pre-allocated trace, as well as POT, you're using hop-by-hop options. And well, that's basically it. So we just need code points for those things from 6-man. And just saying just, it's not going to be a just probably, because we're touching hop-by-hop, right? And that's, but that's it. And I hand over to Mickey for a discussion on raw export, and then, well, we can go and have a closing discussion on maybe the namespace ID and other things that Mickey's going to go bring up. Thank you.
Okay, so raw export. Yes.
This is at the end. Oh, does he have one more after raw export?
No.
We're going to wrap up everything in our discussion. So that, okay. So otherwise, we might not get to this. That's
Okay, so everything we just talked about was pretty much in the data plane. How do we carry all this fun IOAM data from one node to another node? Now, eventually, we want to get it off the network. So this figure is just explaining what we think raw export is and why it's a problem that we're trying to address. So the green on the bottom, packets are going through a bunch of nodes. Some node decides, okay, I'm done with this stuff, maybe at the edge of the domain, take out all that IOM data that we have. Now, what do I do with it? And we're saying that in order to really optimize the data plane nodes and those IOM nodes at the bottom, we want to make the export as simple as possible. So raw export means we're basically taking chunks of packets and IOM headers, stuffing them in a simple format, and getting them off to some data processing system. From that point on, whether the data processing system does analytics itself or it then aggregates or interprets or processes info and then punts that up to an analytics system, whatever you want, right? There's many options for how to put the pieces together. So the goal here was as simple as possible for the data plane nodes. The exporting node does not interpret, aggregate, or reformat IOM data before it's exported. We're offloading all that to the data processing system. So when we looked at what can we do for the format of getting all this stuff off of the system, IPFix is commonly used for flow-related things. Today it's more statistics, but you can also do packet sampling and various things like that. And so we took a close look at IPFix and figured that it already has a lot of the things that we might need, and there's just a few extra information elements that we could add, and then we would have a full format for doing all this raw export. One thing I note, just the bullet on the bottom, that's not actually in text, it's in the draft, but depending on your implementation, if you're highly optimized in the data plane, often in hardware, you're probably not going to support the full flexibility of, hey, tell me what template you want and so on. You may find that an implementation does a small number of fixed formats that it can highly optimize, and that it will adjust alignment constraints and such so that it can process that at billions of packets per second. So among the IPFix information elements that already exist that we can just use, we have an IP header packet section, and note that an IP header packet section, it starts with the IP header, but depending on the length of that packet section, it can keep going into various headers after that, including possibly IOAM that is embedded within. You can do the same thing with Ethernet using data link frame section. And there's other things. There's a section exported octets and forwarding status. If you're reporting drop packets, then you'll find forwarding status of great interest. Basically, the first 3 bits are telling you, did I forward the packet? Did I drop it? Did something else happen? And then the next 5 bits, like if you're dropping, you can specify why the packet was dropped. So what we wanted to add, a few information elements. So one is report flags. Maybe that should be renamed, but it was just trying to give a kind of the broad categories on why I want to report this particular info. So did I drop a packet? Did I see congested queues? Is it just a flow that matched an ACL or something else that said, hey, I want to know all about these flows? Encapsulation type. If it's none, it's just a pure what's in the data draft. If it's one of the others and you start with the shim header that Frank just explained in the various encaps, you go continue on into the IOM data and possibly continue after that. And then you have 4 data chunks corresponding to the 4 type options of IOAM that we have today: the pre-allocated, incremental, end-to-end, edge-to-edge, and proof of transit. So once we have all those, it's up to you how you want to put them together, but we thought it was useful to list some examples of how you might lay out these information elements in a template. So of course, it's not mandated to use exactly this template. The simplest way to go would be to only have most of the info just in an IP header packet section, and then it's long enough that it continues on into the IOAM data after that. You still may want things like the report flags and maybe a forwarding status. Other than that, you throw a length on it, you're pretty much done. Another way to go, you could use the IP header packet section just as more for the outer fields to tell you what the flow is, so you can identify what the flow is that you care about, and then pull out some of the IOAM info and put it on top. And you can do various combinations of which things are fixed length, which are variable length, and so on. So that pretty much covers what's in the draft. I did have some questions, and I sent a more detailed message to the mailing list, but these were more around, there are certain fields, if you look at the definitions of information, almost like IP header packet section, it has certain restrictions, so you have to put things like section exported octets in certain cases. You may or may not be allowed to put padding, and it just seemed like you could cut out a few bytes if we updated those, but that's kind of an open question. Can we change the definitions of fields? Basically, if you go to the ANA registry, you see all this stuff today. And
So, hi, well, I was going to go ahead and get in line, right? Because it's so here. Hi, Brian Trammell, not as chair, actually as one of the designated experts for the IANA IPFix information elements. The short answer to your question is read RFC 7013 and try again. The most of the changes that you're proposing here are non-interoperable with existing implementations, as far as I see, right? Like you're actually like relaxing restrictions that might break collectors that are relying on those restrictions. However, this is not a very scarce number space. We have, it's like you get 15 bits and we're down in the 400s now. So,
so you're saying
if there's enough of a win, it might make sense to do IOAM specific packet section IEs, right? So design what you want.
Okay.
The downside is that, you know, existing collectors will have to then get the update, but you're talking about changing a definition that might break those existing collectors anyway. So it's the same amount of time for the existing collectors to update.
Okay.
Is data link frame section not deprecated? I thought we deprecated that one. Let me go actually have a look at the.
It said current when I was looking
It said
at
current.
it. But
Okay. Yeah, it would have been deprecated along. Oh no. Sorry, no, that one's good. No, sorry, I thought it was a section offset. No, that's fine. Yep. Yeah. So short answer: read 7013.
okay.
slightly longer answer, read 7013 and really consider whether you want to reuse these IEs, because I don't think you can tweak them to be exactly what you want. I think you can basically create new ones by reference. Yeah. Right, but like
Yeah, I mean-
optimizing them will break them.
Yeah, this was all
Yeah.
optimizations. It saves
Right.
you a few bytes. It doesn't
Right.
break the underlying.
Yeah, right,
that I'm
yeah. So,
trying to
well,
do.
you can also use section offset. I didn't see section offset anywhere in the document. So
Yeah,
you can
there's-
actually
I thought I listed, well, I
Okay.
don't remember if I listed it. or
Yeah,
not.
yeah.
So
take a look.
it can be
and-
in there.
yeah.
Just, it wasn't clear to me that it's a big win in terms of.
Right. Yeah. In terms,
Otherwise-
it actually, yeah, it slows you down quite a bit. So yeah, so a little bit of history here. This was all done for a completely different effort called PSAMP.
Yeah.
So it was kind of optimized for that, but not really. So yeah, definitely consider whether or not these are really what you want, because what you're trying to do to take the IOM information out is semantically different enough from just random parts of the IP header that it might make sense to define a new IE anyway. And it's not that big a deal. So
Okay.
I mean, you're already defining new IEs in the document, so one more won't really break the bank.
True. Okay.
Delaney Elkins. I have two different kinds of comments. One, functionally and from a higher level,
Mhm.
this is extremely cool.
Mhm.
Very good data in a, that if we can kind of like, if I'm understanding it correctly, you're going to grab all this stuff passively and then just take the IOM data, which is very cool.
Yeah.
But there are a lot of enterprises have huge passive data capture devices, which are taking the whole packet. You know what I'm saying? And I'm just thinking this stuff out in my head. So I want, do you want to talk about that, to think about it a little bit or discuss or offline?
I mean, the thought here was that you're getting IOAM data at your edge nodes, whether they do any stateful processing to figure out which things they want to export, which things they just don't want to export because they think it's redundant. That's always an option. Usually you wouldn't do the entire packet. You would do some chunk of the packet. And, there are already words in like those IP header, any packet sections and such that you shouldn't do the whole packet because it's security and this and that and so on. It refers to various documents and discussions that have been done earlier. I'm not sure if I answered what you're looking at.
Yeah, we can talk offline. I guess what I'm saying is on a lot of enterprise networks, there are huge packet capture devices already that are capturing the entire packet, including of course, the IOM data comes with it. It's just what's that? Huge packet brokers. Having said that, this is very cool because, you're not having to filter and stuff and it's just the data you want. Is that kind of your point?
Yeah, so
Yeah.
the hope was to do this somewhat intelligently, that based on the data that you were receiving, you could actually decide what you want to keep and what you don't want to keep.
Just a note, we are running up on our time here, so let's cut the line and make this quick.
Yeah, so I'm relaying Jakob Stein, who, as Jabber, who is basically raising the point that anytime you're taking bits of packets as they're flowing by and exporting them, that may raise serious security issues. I'll also note that on that point, when PSAMP went through the whole process, there were a lot of 2804 concerns. So is this wiretapping or not, right? So be prepared in sort of the later process of this.
Yeah,
that question will be asked.
The quick answer was to take exactly the text that PSAMP did in the IP header packet section and frame section, but yeah, whether that's enough, we'll have that discussion.
That was 10 years ago. The world's changed.
Yeah.
Yeah, and I think to the earlier note, this is why you had this two-step approach shown in one of the diagrams earlier, right? So you strip the information off the packet, and then you might pre-process or further process it. And that one step, taking it off and handling somewhere else, might even be in a contained same box still, right? And that might mitigate some of the security concerns, but it might not be by the same entity, i.e. you decouple data plane and maybe the the brain or the control plane portion. I have another question. Can you go to the final slide? No, one further. Just quickly chat about next steps, please.
Yeah, okay, so next step, so the IOM data draft has been fairly stable, and there's a question whether we're ready for a working group last call.
Does anyone object to working group last call on IOM data? All right, we'll go ahead and start one probably after this meeting. I mean, I guess we can do it like right now. Huh? Wait.
So the namespace identifier, we still want to go add,
Oh.
right?
Okay.
And
Right,
maybe
yeah,
we
okay,
do
yep,
that
yep, yep.
after that one, right?
Yeah. So crank the revision and ping the chairs. May be hard. I'm going on vacation for this for a couple of weeks, but Tommy knows how to push the buttons. Sure. Yes.
So just not on the data, but on the encapsulations, of course. One is Genève has the ether type field for next protocol, just like GRE does. And it would be nice if there's a rationale for them being different to have that articulated, because otherwise you're just adding complexity. I don't understand yet why. I'm sure there's a reason, but please take a look at that. And also the packet format for the GRE version doesn't reflect 2890, which updated the base GRE spec. So it should really do that, particularly if people are doing new implementations. So minor points. On the namespace question, I like the idea of namespace. It also lets you do different administrative domains. You can have the ability to say, strip out information when it's crossing a point. So I think it has a lot of power. It also lets you handle, say, overlay, underlay situations. So I think it's got flexibility beyond, and I'm sure you've thought of it, but beyond just clarification of the meaning of the fields involved. I think it lets you do some really useful administrative policies.
So the encapsulation drafts, so 3 of them have existed now over meetings. And so for those 3, we were wondering if we could call for a working group adoption on the VXLAN, GPE, Genève, and GRE drafts.
Sure. Is that something we want to do on the list?
Let's take that question at the end, maybe. Area director interrupt.
Yeah.
Yeah, Mia Kulevin. I should have prepared better, I guess, but it wasn't the original plan to bring this to the working groups to actually work on those protocols.
So can I clarify?
Yeah.
So the idea was to bring them here because there was not a whole lot of interest, but to have all of the discussion echoed over to those lists and to have the working group last call also split out into the appropriate working group for the encapsulations. So basically, it is the encapsulation here. The point of the review here is to make sure that it all works well with IOM, and the point of the review there is to make sure it doesn't break the encaps.
Were those drafts presented at the respective working groups already?
Frank, can you speak to that?
Yeah, so in Genève, we had that discussion. GRE, not so far as I know. On V6, definitely not, because that's brand new.
Mm-hmm.
But again, so the problem that we faced, and we started the other way around, right? NSH was okay. The Genève people in NVO3, well, I'm not saying that they couldn't care less, but there was not a load of energy there. We talked to the Lisp guys on VXLAN GP and the likes. The problem is that you typically start from scratch and explain all the context, and then you get a load of questions on IOEM, as opposed to, we need a code point, guys. All we needed is a code point from you guys. And so we thought that let's mature it here where people have the context. And if people in IPPM think this is okay, then we go and, well, discuss the protocol-related aspects, but not the IUEM-related aspects with the respective working group. I think that was the rationale, because starting the other way around, well, you present and then next one, right?
Yeah. So as far as
people don't have the context and might not even care about the context because they don't care about IOM, right? Because you have yet another person asking for a code point, and that's okay.
As far as adoption here, we were just discussing, and I think we can follow this up on email or on the list. But it would make sense probably to at least make sure that all of the other groups are aware of that, at least in some form, before we adopt any one of the given drafts. So if we've already talked about Geneva, maybe we can adopt that one, but if we want to do them all at the same time, let's make sure that all of the relevant groups are aware of it, at least, before we continue work on that. Right, including 6-man, yeah. So, yeah, thank you. Okay. Yep. That'd be great. Please do that.
It'll take a while starting out.
Yeah. Okay, and we should get moving ahead on our schedule if that's okay.
Okay,
Yeah, okay,
sure.
Yeah, please.
Yeah, so, I mean, as Frank had said, part of the point of, and Mary, part of the point of moving us here is to get the focus. I don't think that due to scheduling, et cetera, that there's been a lot of looking at the impact of some of the, I mean, during encapsulations, but the impact of it. So it'd be nice to at least get routing directorates or, RTGWG or this kind of thing. I don't think there's any concern. I don't think there's a territory argument about, here, do them there. I think consolidating the work in one place with people who really care about it is clearly being very beneficial for the work. It's getting the eyes on, but doing cross-adoption, working group adoption calls or something would be helpful. VXLAN GP is interesting because as far as I know, VXLAN GP isn't standardized or being standardized. There's not an RFC for it. It's explicitly, there will at some point, I mean, assuming that NVO3 does what we agreed on a while ago, eventually, there will eventually be an informational document saying VXLAN GP was a choice that was not selected to be standardized. But I feel like it's a different, this is, there's not a, it's an Ethernet type code point. You need an ether type. Once you have an ether type, you can do all sorts of fun things, right? It is, but that's the piece that's going to be complicated for the VXLAN GPU one. That's all. Sorry to take so long.
So I think what we need to do is I need to have a look at all of these documents because I didn't. But I think it's actually the decision of the other working group to redirect this work to this working group. It's not that we can decide it over here. So it probably makes sense to coordinate between the chairs and the ADs what to do. But I mean, both is possible, right? You can, the question is where to actually adopt it and where to run the formal process, but having a joint working group last call and discussion can also happen in both groups wherever there's more interest. Even if you get it adopted in the other working group, you can still present it here and discuss it here.
Yeah. So this was
recommend that?
Me.
Okay.
That was my recommendation. Yeah.
So I thought I recommended something else initially, but anyway, okay.
Oh, right, but that was before you were AD. So I mean, you can.
Yeah, but that was. Yes.
Yeah. Yeah.
It's it might be the problem is might be recommendation. It might be different recommendation for each of these documents, right? I think for 6-man, the official recommendation is to have it not in 6-man, right? We had that before.
Yeah, we already had that with PDM. Yep.
So it's still the case that you should go there and let them know that it exists, but we can do it here. For everything else, we have to check on a case-by-case basis.
Okay, thank you very much. And reminder for people on microphone discipline, please state your name. There's been some confusion in the Jabber room. Giuseppe, can you put yourself in the queue? There we go. All right.
Hello.
Yeah, so just, we didn't get the request in for remote presenting. So if you can just tell us next slide, we can do that for you.
Okay. This is an update of the multi-point alternate marking draft. So we changed 2 versions since after the London meeting. So this slide gives you a recap about the document changes. We moved from 0.2 to 0.3 version and then to 0.4. We got some comments after London meeting. I want to thank Al, Chin, Tal, Rachel for the feedbacks. And there is a list of the main points that have been modified during the last version. So in summary, we detail better the description of multi-point approach, the example of the cluster, the algorithm for cluster partition. We add more details on delay. In particular, there are two ways for delay measurement. One that is based on multi-point path basis approach, and the other one that is based on single path basis. And then we add the new section on timing aspect that extends the corresponding section of RFC 8321. I want to thank Al for this fruitful input. So next. So in summary, multi-point alternate marking is the RFC 8321 development. So this is an enhancement of this RFC because the RFC 8321 is valid, seems to be valid only for point-to-point, but in this draft we want to extend this definition for any kind of unicast flows, not to unicast, not multicast, but to any kind of unicast flows, but in general multi-point to multi-point flows. And in particular, the multi-point alternate marking approach adds flexibility to performance management, allow an orchestrator to control, and in particular to enable the dynamic performance monitoring, because there is the possibility to configure the desired performance measurement statistics depending on the needs and on the status of the network. So next. Yeah, this is the basic, the base idea that is the cluster packet loss. So in general, if we have a multi-point to multi-point network, we can find a partition of these networks with subnetworks. And clusters are the smallest subnetworks where the packet loss property is still valid. So packet loss property means that the number of packets incoming are equal to the number of outgoing packets. So in general, the network clustering approach is very useful because without network clustering, we can monitor only the entire network or a single flow. Otherwise, with network clustering, we can use the network cluster partition to perform the needed degree of detail. So we can make a cluster zooming on the network, like the previous. Next. So, okay, this slide shows a simple algorithm for cluster partition. So this is a new paragraph that has been added after some comments received. So in general, there is a two-step algorithm. The first step is to group all the links where there is the same starting node. And the second step in join the grouped links with at least one ending node in common. So in the figure, we can see that for the nodes, for the first step, we can have 5 groups. And with the second step, the group number 2 and group number 3 join to have the cluster number 2. So in general, in that multi-point path, we can find 4 clusters. This is just to give you an example on how to apply this two-step algorithm. Next slide. Okay, this is a very new section that has been introduced after the input from Al. In general, of course, if we have a lot of source nodes that mark our traffic, we can have a misalignment between the marking intervals of each marking nodes. Because in general, if we have a multi-point network, we can have multiple marking nodes. So we have to define the measurement intervals. And in that case, we have to consider the misalignment in the timing consideration. So if we want to talk about the precision of this methodology, we have to consider the misalignment between marking source routers in terms of different lengths of the marking intervals and different offsets. And you know that the marking method need to work that the available counting interval will be greater than 0. So if we consider that the misalignment between the marking nodes will be added to the D that already includes clock error and network delay, the condition that must be satisfied is always the same, and is that the available counting interval must be greater. And this gives you the new conditions that make multi-point marking method useful to just in this condition. So next. Okay, this describes the delay measurement approach that can be distinguished into two possible ways of measurement. The first way to perform the delay measurement is a multi-point path basis measurement. So in that case, the delay value is representative of the entire multi-point path. This means that, for example, if we want to apply the mean delay is the difference between the mean timestamps of the set of output nodes and the set of input nodes. So the mean delay is representative of the multi-point network. Otherwise, we can apply the delay measurement on single packet basis measurement. So it became a point-to-point measure, but it is based on the multi-point path. That means that multi-point path is just used in that case to couple the samples between input nodes and output nodes. Single marking based on first and last packet cannot be used because the batch boundary is not valid in multi-point approach. Double marking or multiplexed marking works with a little limitation that are detailed in the graph, but there is no time to explain this. Hashing is a more general solution because clusters simplify the coupling of the symbols, and marking method anchor the samples to a specific period. So next. So this slide details a little bit more about the hashing sampling. So that is detailed into RFC 5475. And the combination between these two RFC give an easy way to perform the delay because we can use the basic cache, so methodologies, where the alternate marking split the continuous flow into marking batches, and this anchors the hashing samples for each period. This is a simple way to apply the hashing methodology, but using basic cache, the number of samples depends on packet rate. Otherwise, we should use a sort of dynamic cache that can be applied with an iterative algorithm, where it is possible to use a number of samples that is almost constant for each marking period. And the detail of this iterative algorithm can statistically converge for each marking period to a constant value of a sample. So also in that case, the iterative algorithm is detailed within the graph, but there is no time to describe it. So next. Okay, this is a typical use case that I have also mentioned in the summary of this presentation. So in general, multi-point alternate marking allows a flexible, dynamic, and SDN-oriented performance management, because if you have the controller can configure a raw performance management, so without examining in depth, and only if we experience some packet loss or the delay is too high, we can go in deep and we can detail about filtering criteria and cluster partition in order to perform a detailed analysis. So this is what we mean for dynamic performance measurement. And there are two ways to calibrate. One way is the flow filtering, and the other way is the cluster tuning, because cluster can be also combined between each other. So next. Okay, just the last slide. that so this methodology adds new points of view to the alternate marking method. It adds flexibility, dynamic performance measurement. It also uses other techniques that are hashing technique, for example, that is not so used, but the coupling between hashing technique and multi-point alternate marking is very useful. And since that we have had a lot of comments, we want to ask for working group adoption.
So hi, thanks, Giuseppe. I don't think we're going to run calls for adoption this time around. We're still trying to drain the queue. Hopefully between now and Bangkok, at the latest at Bangkok. Could I see a show of hands here? Who's read this draft? Okay, so we have a few. I think it seems perfectly reasonable to do an adoption call, but we do try to keep the sort of the docket of the working group a little bit slimmer. We're going to get, so there's one working group last call that's done. We'll see if we can get another one out. I think Stamp is getting pretty close to done as well. And once we get those out, this will be next up.
Okay, we'll wait.
Okay, cool. We'll keep working on it, right? Like, I mean, there's, you know, if running it through and then adopting, and then, you know, we can also adopt and do a relatively quick jump to WGLC as well, right? So the thing is not to have quite such a big list of currently active drafts. So, all right. Thank you very much.
Okay, thank you.
Thanks. So Nalini, if you come on up, we are running sort of like minus a bunch of minutes. We give you a 15-minute slot. You have 14 minutes max. If you can go even faster, that'll let us get to at least one of the lightning talks, which is remote. So yeah.
Okay. No, go ahead. Well, okay. Okay. This one, this draft combines the marking method and also PDM. The reason we did it is because PDM is end-to-end and marking has airing. Marking needed to be V6 stuff, and we wanted path stuff. So these are the PDM fields. That's RFC 8250, I believe. We already have it, and that's the end-to-end information. And you know, you can get the round trip delay. It's all in the destination options header. But what we don't have is the one-way path delay or the middle box stuff. So marking has some real interesting things about it. Is that you can batch packets together and look at the timestamps and stuff, and you can do average packet delay. So with Giuseppe, we were talking about it, and it looked like this might be a way to meet both our ends. So now I'm going to stop talking. I'll go a little bit slower here. This is actually the only slide that's worth looking at. Sorry, I shouldn't have. But this is the only slide that's of interest. What this has, this is the HBH header, and you can see the top part. I don't know if there's a pointer here. The top part has the marking stuff. You can see the marking type, and the reserved field. And the idea is this will go from middle box to middle box, whatever you consider a middle box to be, and we've all thrown that around a bunch as to exactly who is going to update this. What we want is to know. When I say we, I'm talking about the enterprises that I work with, and some people who've looked from ISPs who've looked at it say this is quite a deal of interest to them as well. Is like as it's going along the hop. Where is the packet getting messed up? Where is it stopping? Who's doing what with it? Who's the last guy that touched it that was of interest? And so that's what's in here. We've been through a bunch about what exactly middle box identifier means. We're very open to, very open to comments on that. There is a protocol called MBTLS, or some call MCTLS, and it's a relatively immature right now. But they've got this concept of a middle box identifier. Some people have suggested the IPv4 address, but I don't know how you get that in a 16-bit field. But anyway, we're real open to that. Brian?
Yeah, keep going.
Yeah, we got it. You know, as I say, this is the only one of interest. We room for 5 middle boxes. It'll wrap around. The last M field is the last person, the last middle box who identified, so you can quickly hop down to updating the one that you've got. We're putting this is not gonna, the packet length is not gonna change. The source is gonna put out the whole thing as a null field. And then every middle box along the way is going to say, this is who I am. This is when I got this packet. This is real data. This is the real packets. This is not an active test. This is hybrid measurement. This is not a test packet. I mean, you could devise a test with it, but this is real live actual data. And so he'll just say, this is when I got it. And of course, you would not want to do this all the time. We're envisioning you do this when you have a problem. And then of course, people say, yes, you have the problem. And then you've just exacerbated the problem by adding all this data. And yeah, okay, I know, but it still, I think, could be super helpful. So yeah, any comments on this thing?
Hi, so Brian Trammell speaking as individual. I have just questions on, so like PDM, the scope in here is single administrative domain, right? So you could essentially, your middle box identifiers can be assigned by configuration, by fiat, or by some central controller, correct?
PDM is not single administrative domain, BTW.
Okay.
PDM is internet wide. This could be single administrative domain. I would, it'd be, as I say, I've already had people from ISPs say this would be very cool and they would like to have it. So I would hope this is not single administrative domain.
Okay, so middle box identifier needs to be bigger. It's going to be single administrative. If it's going to be outside single administrative domain, middle box identifier needs to be bigger. You're going to need some way to do. I almost kind of want to just say read the plus drafts and do that instead. But you're going to need, yeah, your middle box identifier needs to be bigger. You're going to need some way to handle integrity protection. You're going to need some way to, like, if it crosses administrative domain where you're not really sure who's going to be messing with the stuff, then you need to go a little bit more complicated than what's here. I have another question, just really clarifying, and I'm going to try and make this real quick so we can get to Ignacio. Why are there packet serial numbers on each hop? Is that like a count of the number? Is that like a packet counter of the number of packets that it's seen, or?
No.
So
basically,
why
it's
is there
kind of like the, you know, the packet number. It's like our packet sequence number. What this tells us is how far this packet get before it got dropped, essentially.
But it's the same for every hop.
Well,
No.
it's the
Every
same.
hop keeps a packet sequence number, like that goes up by 1 for every packet. Got it. Okay,
Yeah.
so it's a okay. That makes sense. Yep. Okay. Yep.
Yeah, and in combination with marking, because if you got a block of packets, no, I think it's anyway. Yes. Yeah, Frank.
Partners, just echoing some of the stuff that we've had to deal with. Timestamp. What kind of format are you going to go use?
Yeah, I know. This is version 00.
So it would be nice to go and get these things fleshed out, right?
Yeah. No, as I said, we're putting this out, and you know, it's getting feelers from everybody. Because I think our first thing is, do people think this is useful? And then we'll continue work on it. That's kind of where we are right now. If people think it's useful, we think it is, but we wanted to do a little, you know, validity testing. Yeah. You can comment to me privately if you want to also. Okay. Yeah. We're also real open to collaborating with, you know, Frank and Shweta and, you know, other people too, and whatever. Any comments? Otherwise, we'll let some other people have a chance to speak. Okay. Thanks.
All right, thank you so much. Yeah, and I think based on comments, it does sound interesting, but we just need more fleshing out. Yeah.
And please take comments to the list. So, Ignacio, we got your 5 minutes. Let me go ahead and pull it up. So, here he comes. Good.
Yeah.
Great.
Hi.
Great. Hi.
If you could put, because this is okay. Thank you. Well, just this is a proposition to get synchronizing internet clocks in secure way, and who is needing which application, measurements, our working group, localization, crypto coins, games, and there are surely another applications. Next, please. Well, this chart represents more or less the error that you can get in different protocols. And the idea is our protocol is the green one, SIG. You can get frequency synchronization in some kind of secure way. Next slide, please. Well, the idea is that each packet is signed in the third way. The error is around 20 microseconds. We synchronize frequency, and it's a client-server simple software distribution. But if there are symmetric paths between server and client, you can also do an absolute clock synchronization, and this is related with the another draft that we got here, the Aura one. And you can clone, you can get the code of the idea in that link. Next slide, please. And this is the updates that we got from the first to the second version. New author is added, Rudiger Geb. We stressed the frequency objective, and we compare with the ITU related standards, and we provide detailed information about security issues, and also an example of some kind of limitation with NTP in some regions of the internet. Well, this is all. I don't know if I can get a question or not.
Could you repeat that?
Yeah.
Seeing questions?
All right, no questions at the mic right now. Thank you.
You want to do some lightning talk in 2 minutes?
Yeah, should we? Do we have time for the next one?
2 minutes.
All right.
Next one in 2 minutes? I don't know.
Thank you.
I think Tianwen, just very quickly, you have two. Which one do you want to give? The young model? All right, let's hear that.
Wait, you gotta give him a mic. You got all that? It's right there. There we go.
This is the young data model for IOM. Last time we presented this in London, and we got several comments from Greg and Rashad. And we make the 4 IOM option profiles as features for flexibility. We modified the ACL leaf to align with the latest ACL model. And we add admin config container for a clear hierarchy, and we also modify the security considerations and the IANA considerations. Here's the overview. The IOM model is organized as a list of profiles, and each profile associates one flow with the corresponding IOM information. We use the filter to identify a flow, and there are 4 sub-profiles, each of which relates to one IOM encapsulation types as defined in the IOM data draft. And the multiple IOM data types can be encapsulated into the same IOM header. And the sub-profiles, including the pre-allocated tracing profile, the incremental tracing profile, the proof of transit profile, and the edge-to-edge profile. And for we imported this proof of transit profile directly from this proof of transit document. And there was a discussion in the mailing list whether to incorporate this profile directly into this IOM model. But finally, we discussed with Frank, and we decided not to do this. We decided to leave it separately and independently. And next, we welcome more comments, and we also hope this can be adopted as the working group document, as the IOM data draft is already stable. That's all.
All right, thank you very much. IOM folks, does that sound like a plan? Okay. So, I mean, yeah.
Frank Faulkner's, yeah, I do like that work, given that I'm co-authoring. So I do think it's useful, and it needs to happen, and we need something configuration for IOM.
All right.
And well, that's the game in town. Yeah.
Let me ask you another question. Would you be scared if the chairs imposed an experiment on your Yang model by fiat? We're looking into using GitHub for Yang model development as opposed to the document stream for inside the working group. I've been asked by some of the NetMod people if we can try that out. I have no idea what it is. I'm going to find out what the actual details are on Friday. So if that's not scary to you, then we would try that with this when we.
Yeah.
Right.
Yeah, we can.
So we'll try and bring this in with the other gigantic pile of IOM documents sometime between now and. We're going to count all the in-caps as one document against the document cap, but because otherwise we'd never be done, right? We'd have just race condition on the number of documents in the working group. So yeah, we're not going to do the call for adoption now. We'll do it with the rest of those. We're going to look into how we would manage the Yang model with this new process that I don't know anything about other than GitHub.
Okay.
And we'll work from there. Cool. All right. Thank you very much. That was IPPM. I won't. Tommy, we'll see you all in Bangkok.
And for the lightning talks that we did not get to, apologies for that. And if you want to send out any summary of that information to the list, that would be appreciated as well.
And if you haven't signed the blue sheets, please come up and sign the blue sheets. Black screen. No idea. I just closed.